Hello friends, welcome to this exercise on how to service an induction heater and microwave oven. At the end of this video, you will be able to dismantle the induction heater and identify the faults and replace faulty ones. Dismantle the microwave oven and identify the faults and replace faulty ones. Assemble the induction heater and microwave oven and test their functioning.
Let us briefly discuss the induction heater. Induction heating is a contactless electric heating process working on the principle of electromagnetic induction. The heat is generated within the conductive material without making direct contact with the source. Here, the object that is heated is referred to as a workpiece, and the coil that induces a current in it is referred to as work coil. Induction heating works by first passing a high frequency alternating current through the coil, which serves as the primary winding. This causes an alternating magnetic field to surround the coil and create flux. This occurs because of Faraday's law of electromagnetic induction. The workpiece is now inserted into the coil and behaves as a single piece of short-circuited secondary winding. Then, the magnetic field of the work coil induces EMF in the workpiece, resulting in the flow of eddy current through the workpiece. Furthermore, this operating principle is comparable to that of transformers, which follow Faraday's law. Tools and instruments required for this exercise are Electrician toolkit, metal brush, soldering kit, tile cutter, induction heater, electric oven, cotton waste, thinner. Now let us start the service and repair of induction heater. Note the nameplate details of the induction heater and record them in the table. Disconnect the power supply from the induction heater. Check the power cord for continuity and short circuit of the cable. Visually check the cable for any damage. Let us learn to check the continuity on the power cord. Usually, the power cord will be 3-core with 3 pins like phase, neutral and earth, identified with red, blue and green colors respectively. Set the digital multimeter to continuity mode and place the probes between the wire end and the corresponding pin on the plug to ensure that you can hear the beep sound. Do the same on the other 2 wires. If no sound appears, conclude that the power cord is damaged and replace it with a good one. You can also use test lamps to verify the continuity between the wires. If the test lamp glows, the wires are good. If not, replace them. Testing cables for short circuit. Set the digital multimeter in continuity mode and place the probes between the 3 pins like phase and neutral, phase and earth and neutral and earth. Ensure no continuity or beep sound occurs in the multimeter. If found, conclude there is a short circuit between the wires and replace it. You can also use series test lamps between the wires or pins to check for short circuits inside the cables. If the test lamp glows, it is defective. Replace it. Open the induction heater by removing the screws using the appropriate screwdriver. Do a thorough cleaning of the PCB, printed circuit board and other parts. Remove the main board for visual inspection and troubleshooting. Visually check the other electronic components for burnt black deposition like resistors, capacitors, diodes and ICs. If found, replace them with good ones. Check whether PCB is covered by varnish. Apply thinner, rub with metal brush and scrap with a knife and expose the dry solder points. A dry solder joint is a soldering defect that occurs when solder does not properly adhere to the component leads and PCB pads. It results in a weak and unreliable electrical connection. Factors such as insufficient heat, oxidized surfaces, improper soldering, or using low quality solder causes dry joints. Retouch all the points with fresh solder. Check whether any capacitor is cracked in the PCB. If so, remove it from the PCB with the help of a tile cutter. Check the electrolytic capacitors on the board and replace with a new one if they are found at the brim. Press the switches on the control board, and if they show resistance, it may be due to improper contact. If the buttons are slightly longer than the one on the board, nip the extra length with a tile cutter tool. Also check the resistors with the help of a digital multimeter to see if they display the resistance value and verify with the color coding technique. If no value is displayed, replace it with a good one with the same specification. Also check the transistor using the diode test position. Remove the cooling fan and check with 12-volt DC supply separately. After completing the work, put the PCB and other parts back into the cabinet. Test the appliances with supply for its working. Let us briefly discuss the microwave oven. High-powered microwaves are generated that falls on the foodstuff. These waves heat the molecules in the food particles evenly and cook the food. It consists of a microwave generator called magnetron, which uses electricity from the power outlet and converts into high-powered microwaves. The food compartment is made up of reflective metal walls, just like a mirror, to have effective focusing of microwaves onto the food particles. A rotating spinning arrangement called the turntable is used to rotate the foodstuff to cook the food evenly. Food to be cooked is placed on the turntable and the electricity is switched on. The magnetron converts the electrical energy into high-powered radio waves called microwaves. The magnetron blasts these microwaves into the food compartment through a channel called a common wave guide. The microwave bounces back and forth between the reflective metal walls and reaches the food. This microwave penetrates inside the food and makes molecules vibrate. The vibrations will cause heat, and faster the molecules vibrate, hotter the food becomes. Thus, microwaves pass their energy on to the molecules in the food to cook it. The food is evenly cooked by rotating the turntable slowly so that the microwaves pass through each part of the food. Now let us look at service and repair of microwave oven. Identify the oven model number. Turn off the power supply to the oven at the breaker box and unplug the oven. Remove the screws to dismantle the outer cover of the oven. Remove the power cord and test it for continuity and a short circuit. The magnetron's wires and plugs must be unplugged. To discharge the capacitor, press the terminals of an insulated screwdriver against the capacitor. You run the risk of suffering significant injuries if you discharge the capacitor with an uninsulated tool. After discharging, test the capacitor using a digital multimeter in resistance mode. When you place the probes on the capacitor, the multimeter readings show some readings initially and move to infinity if the capacitor is good. To acquire the most accurate reading from the magnetron, put the multimeter to the lowest ohms setting and turn the dial to the smallest resistance listing. Place the multimeter probes on the terminals of the magnetron. Hold one of the leads from your multimeter up against the prong's side. Next, attach the second lead to the opposite prong while ensuring the multimeter leads don't contact. The magnetron's electric filament operates properly if the resistance remains below 1 ohm. The magnetron must be replaced if the reading is higher or if OL or open loop appears on the screen. Now set the multimeter to the highest range and place one probe on the terminal or prong and the other probe anywhere in the metal box. Look at the multimeter's display. If OL or open loop is displayed, the magnetron is functioning properly. Replace the magnetron if any other readings come up. After checking these conditions, if found good, mount the magnetron back to its original position and wire up as before. Plug the oven back in and return the breaker back to the on position. Test the oven with supply for its working. There may be a little smoke when new elements heat up. It's likely just the factory coating burning off.
I hope after watching this video, you will be able to dismantle the induction heater, identify the faults and replace faulty ones. Dismantle the microwave oven, identify the faults and replace faulty ones. Assemble the induction heater, microwave oven and test their functioning. This concludes the exercise on how to service an induction heater and microwave oven. Thank you. See you in the next exercise.